A function f from n plus to n plus defined on the set of positive integers n plus satisfies the following properties. F of n equals f of n by 2 if n is even. F of n equals f of n plus 5 if n is odd. Let R equal to set of all elements I such that there exists j, f of j equals I, be the set of distinct values that f takes. The maximum possible size of R is dash. So this is an interesting question coming from engineering mathematics in set theory. So they have given us a function f that is defined from the set of positive integers to the set of positive integers. So domain and range are both same here, and this function satisfies these following properties. F of n equals f of n by 2 and f of n equals f of n plus 5. This if n is even and this if n is odd. So please note that they are not saying f of n equal to n by 2, they are saying f of n equals to f of n by 2. Okay, and they are given this set R equal to set of elements I such that there exists j such that f of j equal to I. So this is nothing but the set of distinct values that the function f can take. Okay, so they are asking what is the maximum possible size of set R. So let us rewrite these properties again here. So if f of n is odd, f of n will have the same value as f of n plus 5 that is given in the question here. Also f of 2n. Why I have written this is consider the value of f of 2n. Now you know 2n is even, obviously, because 2 is a factor, right? So for f of 2n will have the same value as f of 2n by 2 that is given here in the question. If n is even, it will have the same value as f of n by 2. So f of 2n will have the same value of f of 2n by 2, that is nothing but n. So if n is odd, we can write f of n plus 5 and f of 2 into n will also have the same value as f of n. Similarly, if n is even, f of n will have the same value as 1 f of n by 2 that is given in the question if n is even. F of 2n, that's because just like we did here, 2n is obviously even, meaning f of 2n will have the same value as f of n here. Also f of n minus 5. Why I have written this is if n is odd, f of n will have the same value as f of n plus 5. Now if n is odd, n plus 5 will always be an even number. So f of n plus 5 will have the same value as f of n when n plus 5 is even, so that I can rewrite as f of n when n is even will have the same value as f of n minus 5. Okay, so I have written these values here. Now let us try to find out what all distinct values the function f can take. Now I have written it in a graph form here, so it's not a graph question, I have just written it so that I can join all the values which have all the f values which has the same value, and I can put it together in a easily readable form. Okay, so let this node represent the value of f of 1. Okay, it can be any value that is not given in the question. F of 1 can be anything. So let us take some value f of 1 denoted by this circle here. Now f of 1 will have the same value as when n is odd, f of n plus 5 and f of 2n. Okay, so f of 1 will have the same value as f of 1 plus 5 is 6 and f of 1 into 2 that is 2. Okay, so I am just writing here what I have written in this graph means that all the nodes here will have the same value for f of that value. Okay, so f of 1 has the same value as f of 6 and f of 2. Now let us take 6 here. 6 is even, meaning f of 6 will have the same value as f of 3. So I have drawn a node for that and I am joining it here. F of 6 will have the same value as f of 3. F of 6 will have the same value as 2n, that is 12. Also it will have the same value as f of n minus 5, that we have already started, right? F of 1, it's already there. So let's take a look at 2. It's also even, it will have the same value as 2 by 2, 2 into 2 and 2 minus 5. So this f of n will have the same value as f of n minus 5 only if n minus 5 belongs to the set n plus, right? So 2 minus 5 is a negative value, so that doesn't belong to the set n plus, so I won't be writing this part here. So f of 2 will be having the same value as 2n, right? So it will have the same value as 4. Now if you take a look at this 4, you will see that f of 4 will have the same value as f of 8. Similarly, this I can keep on drawing it by multiplying it by 2, keep on drawing it like that here. Now for 6 we are already found out that f of 6 will have the same value as f of 12. 12 is even, so it will have the same value as 12 minus 5. So I can write the bubble for f of 7 as well. Similarly, f of 7 will have the same value as 2 into 7, that is 14. f of 14 will have the same value as f of 14 minus 5, that is 9. So I can keep on drawing it like this and I will get a bunch of values which belong together, right? So if you see, none of the numbers here are a multiple of 5. So there is no property, and I've just kept on drawing this and I just found out that none of the numbers here are a multiple of 5, right? So I will start a new bubble for 5. Let us say this bubble represents the value of f of 5. So f of 5 is an odd number, so I can write 2n as well here. So f of 5 will have the same value as f of 10. f of 10 will have the same value as f of 20. f of 20 will have the same value as f of 40, etc. f of 20 will also have the same value as f of 20 minus 5 as given here. So 20 will have the same value as 20 minus 5, that is f of 15. 15 will have the same value as 15 into 2, that is 30. 30 will have the same value as 30 minus 5, that is f of 25. Similarly, I can keep on drawing here. So what you will see here is that once I keep on expanding it, this will cover all the multiples of 5, that is 5, 10, 15, 20, etc. All the numbers here will have the same value for the function of that number. f of 5, f of 10, f of 15, 20, etc. will all have the same value. Similarly, if you take a look here, 1 is here, 2 is here, 3 is here, 4 is here. Now 5 belongs in this set, 6 is here, 7 is here, 8 is here, 9 is here, 10 belongs in this set, right? So we can stop at this point, we can keep on drawing it and find out, but what we'll see is that all for n which is not a multiple of 5, f of n will have the same value, and if n is a multiple of 5, it will have a different value. So f of 1 and f of 5 were our starting points. So if we assign f of 1 some value and f of 5 a different value than f of 1, we will see that the f can take a maximum of 2 distinct values, that is one value for all of these and one value for all of these. If f of 1 and f of 5 we were taking the same value initially, then all n will have the same value only. So in the question they have asked us the maximum possible size of n. So the maximum possible size of n is, as you can see, there are only 2 sets here, that is 2. So 2 is the answer to this question.